Hi guys, this is Sam here. So today we are focused on basically hardware connections on this little model 3B Connect of the Pi, and it's an awesome. I have a GNS system, and again I generally don't connect it and with a keyboard and directly work on that. What I do is I connect basically. It's easy. I can have a SSH session open to that to this guy and do that. So today we'll work on the SSH session with this monitor HDMI is to show that hey, we have a totally independent system, which is our model Pi, and it's a totally independent system. It is more about of an IO controller. I'm gonna basically do a warm, basically a little library and see. I want to basically make sure, hey, from my C code, I'm able to basically warm up, right? I'm able to access its controller and send the controller commands to the output. So I have a crowbar here. So there is a breadboard. Let's focus on this. Is a beautiful thing. I very much like it. It has a USB ports and it has a HDMI port and a power adapter, which is USB-C micro. One of the things that I fable was, hey, what is this? Its outage is 2.5 ampere maximum. So basically the Pi doesn't need much. It needs 700 milliamperes at 5 volts. Okay, but it goes up to 1 ampere. So if you have a power adapter 1 ampere, don't do it. I mean, if you're trying to connect with the HDMI and other USB ports, then the power consumptions increase up to the probably 2 amperes. So that's why I have this adapter. My first thing when I was not getting adapter, yeah, why don't I use a 1 1 ampere? That's a bad idea. I didn't try that. So I had this one, and this is doesn't get too much hot, so I don't need to put heat sink. Let's focus on the very purpose of the GPIO board, right? That's what we are out here. So this is a GPIO board, and let me tell you the GPIO board. If you focus onto that, this is beautiful. All the physical pins settings are there, and it has basically put a GPIO, basically general purpose IO thing, and the ports are there at GND. One of the fascinating things that is we need to understand it is a 5 volt and a 3.3 volt system, right? For all our treat this is an IO input output control system, a dumb input and output controller. Yeah, so like a microprocessor, you can send the command to an input port, high or low, and make these devices peripheral devices, which could be LED. I have a potentiometer also here, or any digital devices you can connect to this IO ports and basically run it, right? So one of the very good system is I have this crowbar here and the ribbon here connected to this one portion of it. So I have the port. So let's go to the hardware port and understand. It's very important, and I've used the jumpers so we don't get short circuit. So we have 3 volt here. Plus minus. So even if you look at this guy, this is the nearest port. So one port of this is a ground port. So the inner port is a ground port, and then you have a 3.3 volts, and then you have a 5 volts. So you see out here, this is 5 volts and TXT line, and this is 3.3 volts plus and minus. So I have connected the 3 LEDs. If you see draw a diagram, it's very simple. I'm using a 17 GPIO 17 port. This is 17 port, the red wire that you see, that it goes out here, and I put it to the LED, and to the LED it's very simple. We know that in LED you need to put a basically resistor, right, to make sure that you don't burn off them, right? And then the ground is connected to this. So similarly I have a green and other LEDs and a potentiometers all set up onto this one. Our purpose is we have an input. It's very simple. What we're going to do is we're going to warm up and say we have a awesome microprocessor kind of a system which is out here, and we have our C code, which is rich library, and we want to little drive the input and output as an IO system, right? And then we will little go in later in other videos. I can say we can do the potentiometer and Bluetooth kind of things onto this. So I have done an awesome on the Python. So with the Pi blue controller on the devices, but focus on this word today will be using our C. Right, we will use this as an IO controller. So we're gonna warm it up and test our hardware connections. Basically make sure that, hey, am I connecting my IO devices ribbon properly connecting? Is the connection of GPIO pin 17 correctly done to the LED? And the LED ground is ground nicely terminated it. If it is, then if I send a little signal to GPIO pin 17 high or low, the LED should blink and I can put a sleep mode, right? And I'm going to basically also make a connection from this guy to my SSH connection from my Mac, so that I can basically work seamlessly from there. So let us do that. And also I'm going to power off my device right from here. Let's go out here and do this. Here is my screen here. I go out here, I'm doing my SSH. This is my if config. If you see, it is 144. So beautiful. So if you see EF config, the port number is Ethernet is 144, right? Okay. So you see flag here 144 INET address. Beautiful. So we're gonna put this one. This is to this. Now let's focus on this. This is just to display to show that hey, I have a full-fledged Pi running onto that. But we are not going to use our keyboard and mouse which are connected. We'll do a SSH session to Pi and run the command from here. Okay, so I have my SSH Pi here. I'm going to do SSH Pi 1044. It asks me part. It says, well, there is a device 44. It is live. So I'm able to log on. So you see, it's a running thing and applicable. And I'm going to say, hey, where I have a home Pi directory. And I can say, hey, the quickly command df. So it shows me the file system out here. Awesome. I'm going to clear the file system. I'm not interested in the file systems here to see df minus h and all. I'm more interested into testing my hardware, connections on the crowbar. So I have my folder out here. I'm going to go to this one, and I have a so I have this written a genuine LED code out, and I can Vim also. Let's go out in and run this file. So because we want to test it out, right? So not okay. So you see, I am doing this and watch on these LED lights. This red color LED light, because we are sending to a signal GPIO port number 17, and we'll see that programmatically it is very easy. This is more about the connection on the hardware. The code to do the IO controller is very simple, all right? But if these are not connected properly, we'll have a headache, all right? And we were not able to debug it, understand. We might burn the things. So we go out here. So you see, the LED is blinking for 1 second. Again 1 second, again 1 second, and keeps going on. And you focus on it. It's also giving a printout over saying LED on, LED off, LED on, LED off, right? And guys, this is I'm using the compiler C code, which I built it out, linked it out my out file, right? And this is to Janu, the Sweet Janu. So Sweet Janu has basically put a code onto this one to make this IO controller. It's driving an IO controller LED on and off. It's not a big code. The more about this particular session is on the hardware side. We want to say that, hey, what is GPIO board input, and how do when I connect a connection, I should be able to test it, right? That my connections are working. Once my input output systems are connected, I can take my LED and put it to some other output device, right? Just replace this guy. Or if my input is set correctly, potentiometers, I can operate that. I can use which will come to the different model. At the same time, there's a Bluetooth controller, right? That we can program it out here for do the Bluetooth devices. So let's focus on LED on and off is happening. 1 second, you see LED is going on. It's going in a while loop, and we'll go to the code. Code is not a big. It's more about, again, this is more about this video on the hardware side to warm up. To see that here my all connections are good. I understand my GPIO board. We are able to connect it, and all these are seamless. If these devices are correct, we can now change our IO devices to better one where we require, and we can do the code a little better. So let's kill this particular code out here, okay? And this is the code here, and let us. Okay, I'm going to quickly VI the file, and this is the LED file to give what is it? This code is very simple, right? I have written more better code with 3 LEDs and other things, which will go, but this is more about, I lied it about. I'm using this GPIO pin, and this is a wiring Pi setup, right? And this is just to, again, guys, to warm up. This is not about a coding session here. This is more about a controller testing that our hardware connections are there. I'm using a wiring Pi model here. So what this library does is it sets the mode. So set up the wiring Pi mode, right? To that, because GPIO is a mode is there that I want to use a GPIO mode or a physical pin. And there are similar, just like wiring library, there are different libraries on if I'm using the Python library or other things. So I have done on the Python one, this we're focusing here. I put the pin model, I have a LED. So by default, this wiring guy says, if you say LED pin 0, it is in the header file fine, this is pointing to GE pin system. You can go to its documentation and it will tell you all what is this, macro to define the different pins which correspond to which GPR pin, all right? And once the pins model, so we will say it has a digital write. All these are coming from the wiring pi. So digital write is outputting to the low signal, LED is on, all right? And then I put a delay for 1000 things to basically sleep, right? And digital write high, and then digital things written. We could have written a little, multi-threaded systems, one thread for controlling this one input, another for, but we are not doing that session because this is more about to make sure, hey, my connections on this pin GPS system are set it correctly, right? You can change the delay and then you can compile the code also, right? So I'm going to quit it out here because this is very simple. It's more about it. You say the skin of all, and I can again, you can go out here with, okay. So let's go out here and let's compile it. Let's change this value to we'll increase the timing and modify our code so that it's not a big deal. Okay, let's go out here and say, hey, I want to change my time. I don't want for once a LED on. I want to make it for 3 seconds. Okay, so we will make the LED on for 3 seconds. Okay, 3. Okay. Sorry about this guy. Okay, file is messed up. Will little go little by again. 1 second. This looks like. Okay, looks like the keyboard issue is there. This minute, my little escape is not working. It happens sometimes. You things, and sometimes you can use settings on this. Okay, and okay. So we already have this connection on the Pi, which is already being edited. Let's quickly close this guy, and okay, so beautiful. It is giving us okay. So we go out here. So it is delay 3000 is done. So let's escape. I'm gonna do this. Yes. Okay, and it's done. Okay, so let's compile this guy. Okay, So I'm gonna do LEDC with LED out, okay, and it is done. So let's run it out now, right? So good question, good thing that we saw that little VI thing showing that the interface was really there, and little, the VAS setting was freaking out. So now we run this one. Let's see this one. LED on, you see, is taking more time. It's 3 seconds now, right? So LED on and off. So you see the time is increased. We are now off for more second. By what happens is when you say LED on, the low and high signals on the library are flipped off. You see, it is off for 3 seconds, okay, and on for less second, because the flag is inverted, right? When you say on that code, because high and low are inverse, right, on the right. So that's why you have now 3 seconds is going to be off, 1 second is going to be on, all right? So we are able to see that programmatically our IO controller is wired up, and we are able to basically see that all the connections are working thing, and the whole hardware setup is done, and we can basically program it. We can now do the programming portion of it. So I'm going to basically close this file beautifully, all right? And this is one, and this is off. And I'm going to basically go out here and say, wait a minute, I want to shut down my command. And this is one of the things, because I don't want it to get warm too much, right? Okay, and it goes out here. You see the Pi going off, and the Pi is off. The light is blinking and it's gone off. Thank you guys. Have a great day.